this is a quick recap on use case diagrams, UML for short. Or well, use case diagrams, class diagrams, which is part of UML, Unified Modeling Language. So firstly, what are use case diagrams? So here we're trying to describe the users of the actors system, list all the use cases, processes, or the functions, the things that they can do, and then show who can do what. So this is what a use case looks like. It's an oval shape. This one is security screening. So it's a business case. So imagine you had a system and it had to security screen people before it could add them as users. It shows the end goal of a user. And it shouldn't necessarily be simple things like login or sign up. So sometimes there are certain things that can be assumed that may need to be done by a user that are part of a bigger process. But it could be something like purchase an item, but you don't need to show that you've logged in or signed up for that. And then you've got actors or users. Don't have to put their name, you just have to put their role. So for example, this is a tour guide, so it could be any tour guide, and who's that tour guide is going to use the system. Here's an example of an online shop. So we've got several different use cases, and several two actors, an admin and a visitor. And a visitor can use this one, or because there's an arrow pointed into that, he can place an order. So the visitor can place an order. The visitor can cancel an order, and the visitor can manage an order. Right, so there are three different things it can do. The admin can also cancel and manage, but only the admin can change the order or update products. So that's how we show the connection of these actors to these processes. So it's quite simple, it's quite straightforward. And the idea here is to really sort of brainstorm with the system that you're trying to create and think of all the different processes and all the actors and who's going to use what. Here we can show extension of different processes. So this is where it gets a little bit more complicated, but sometimes some processes are simply extensions of other ones. So ordering wine is just an extension of generally ordering food. When you order your food, you order your wine in this restaurant example. Serving food is an extension of serving wine. Eating food and drinking wine. So you can make these quite complicated to show which processes could be extended. Okay, so let's jump straight into example. An example. Here's one I've made earlier. When you create this, you go to New, File, New. If you're using Visio and you use UML, search for that, and you choose this UML use case diagram, and you click on there, and it will create a blank page view. And then when you want to add an actor, you drag it in over here, and you double click on it to name it. So I've named this one client, this one hairdresser, and this one admin. So here we're trying to model out all the different possible use cases, functions that we're going to need to program into our system. So it's a little bit like the data flow diagram, but not quite as complex. You're not showing where the data is going to be stored. You're literally just talking about almost a code level tasks that we're going to need to program in. So for example, for a client, we're going to have to find a way of programming how to make an appointment. Also, for a client, we're going to need to find a way for them to leave feedback on the hairdresser, or perhaps the hairdresser on the client. But the hairdresser is the only one who's going to be able to cancel an appointment. The client's the only one who's going to be able to accept an appointment, and the payment is only going to be done by the client. I'm not sure why there's an arrow here, but the hairdresser is the only one who can enter his availability. Delete that one. If you want to draw connections, I use this generalization arrow, and I drag it onto, say, the client, for example, and then I think the client can also cancel an appointment. So, and so on and so on. You need to add in all the different processes that you're going to program. And then from the UML diagram, we're able to create something called a class diagram. So I just need to update that. Right, so a class diagram. What have we got going on in this class diagram? Well, it's basically to define all the groupings of things in your system. Class diagrams use inheritance, they use properties, and they have functions. So here's a simple example of a class, an animal class. We have name, which is a type string, ID, I type int, age of type int, and then it's got two functions. You can set the name and you can eat. So the bottom bit shows the functions of that particular class, and the top bit shows the properties. And next to it are funny symbols like hash, hash, hash. So what that means is it's about levels of protection. So sometimes we want things to be public, so we use a plus. Sometimes we want them to be protected, so we use a hash. Sometimes we want them to be private, so we use a dash. The private means only the things inside of that class, or only the functions inside of that class can change the variable. Protected means the things inside of that and also its subclasses, as you'll see in a minute. And public, the plus means public. Anyone outside of that can change the value of that property or call that function. So private, public, and protected. It's much easier to understand these things when you put it into an example, as I'll show you in a minute. So this is what we're talking about with inheritance, and you'll see why these protection levels matter with this. Animal is extended by tortoise, otter, and a slow loris. So these are different types of animals. So every animal has things in common: a name, ID, age. They also have properties that are in common, functions that are in common, like set name or eat, but they differ slightly. So a whisker length is something unique to an otter. So what we say is otter extends animal, inherits everything that an animal is by drawing this arrow with a white empty head, but it has an extra whisker length, which the tortoise and the slow loris wouldn't have. So let's come on to the class diagram. So here's one again I prepared earlier. Now, in our hairdressing appointment system, we have a main superclass called user. And then we have 1, 2, 3 things that inherit from user. So what inherits from user? Well, client inherits from user, hairdressers inherit from user, and admin. Why? Because they're all types of users, but they differ slightly. So, for example, every user has an address and a name, and therefore every user should have and those are protected. That means that they cannot be changed. They can only be changed in extensions of this class, but not outside of the class. So it's like protected, but it's not quite as strict. And then you have the different functions. So we need to have getter and setters for protected and private variables. Why? Because we cannot change these directly. We can't change the value of name or address, and we want to define how they're changed. So we use a getter or a setter to change it. And then what are different between the users? Well, a hairdresser has a rating, and a client has a history of appointments. Clients can make appointments, clients can cancel appointments, but only hairdressers, you can get their star rating or set their star rating. And they can also cancel appointments as well, but they're the only ones who can update their availability. You see, we can get all of this information about the type of functions that we need to decide which class it's going to belong in by looking through our list of processes or use cases from our use case diagram. That's why it's important to do this one first, and then you have a better idea of all the functions and things that you're going to put in here. Now, this is the last connection. This is composition. So we say that a client has an appointment, but a client is a user. So that is the difference between inheritance and composition, where you're trying to describe that relationship. The client is a user, but the client has an appointment. And what are appointments made up of? They're made up of time, which I didn't put its type, but probably an integer. Date, it's probably another, like maybe a string. Style could be a string again. Which hairdresser? Well, that could be a string maybe. And who's it for? That could be a string as well. Imagine these are perhaps IDs of the hairdressers and the clients. Something we need to be clear about and define later. But yeah, an appointment, a client has an appointment. So when a client has an appointment, he can make an appointment. And when he makes an appointment, it probably calls a function in appointments that will then create this record time of the time, date, style, who's going to do it, and save it to the database or whatever. So if I just flick back to these notes, composition. Also with composition, you can say something about its multiplicity, like how many appointments a client can make. Well, a client can make many appointments. In this example, we have a visitor center. How many, a lobby has a visitor center, but only one, but the visitor center only has one lobby. But the visitor center can have one or many bathrooms. So it's really important to understand that difference between inheritance, where we inherit all the properties of that superclass, and has a relationship or composition. Now, if you look at this, we'll see that if I look at this diagram, you see that I'm making proper use of the hashes for protected. Why? Because address and name are things that need to be used in this class and any subclasses. So we need to access them and change them. But something like history of appointments or star rating is something that should only be able to be accessed or changed in that hairdresser class or in that client class. It doesn't need to be changed outside of that class. But the public, but I'm using public for the get and set of star rating because we're going to need to access that outside of it. And as long as we define in those functions how we change the star rating, like add 1 to it only, then that's okay. But they need to be public so that we can change them. And the same thing for appointments. These are all private. They don't need to be changed outside of it. And in actual fact, as a general rule of thumb, you should make all properties and functions of a class private until you've got a very clear reason or you're quite clear that they need to be public from the start. So that is use case diagrams. They describe an overall use cases of the system and who's going to use them. And then UML diagrams, which go into a lot of detail. So UML class diagrams, which go into a lot of detail describing all the properties of the class, the functions of the class, and whether they're going to be public, private, or protected. And you can represent all of this in the class diagram here like this, and in the case diagram here like this. And I will put examples of this in the link below this in the Medium article, so you can refer back to it and look at it. And finally, if you are in my class, this is what you need to write up in your report. So you can pause the screen there. You've got to show Visio, UML case, and UML class. Create the use case diagram first. Then describe the actors and the use cases, and then UML class diagram for the hairdressing app. Describe the classes, the properties of each class, and the functions, and then the relationships between them. So you can just screenshot a lot of this work that you do in Visio and then put some descriptions below it. And that's all you need to do. Good luck.